This is a continuation of learning about powers and exponents. So we have already completed in class the other pages. So this is the third and final page, and we're going to talk about power of a power. So right here, I want you to go ahead and fill this in. Review of exponents. Complete the statement by filling in the missing words. So think about when you're multiplying powers with the same base, you do what with the exponents? You divide powers with the same base, you do what with the exponents? All non-zero bases raised to zero power equals what? And then find the value of each power. Right now, go ahead and leave that as a fraction. And remember, what's a negative exponent, as of right now, go ahead and leave that 1 over 4 squared, which we will talk about. 4 squared is 16, so that will end up being 1 over 16. But right now, I'm okay with you leaving it just 1 over 4 squared. Remember that negative exponent makes it go down to the denominator if it's in the numerator. So that's in the numerator because that's like over 1. And so it's actually bringing it down to the denominator. Okay, so now we're going to find out what this is doing. This is power of powers, which means I want you to write this out, expanded notation. 5 squared means 5 times 5. Well, this exponent 3 means you're doing that 3 times. You have 3 sets of 5 times 5. So you're multiplying 5 times 5 times 5 times 5 times 5 times 5. So the exponential notation would be 5 to the 2, 4, 5 to the 6th. Okay? This one's going to be negative 4 3 times, negative 4 3 times, and then 3 sets of that. So the negative 4 3 times, and then negative 4 3 more times, and negative 4 3 more times. So that's going to be a total of 9 negative 4s. Make sure you have parentheses. So hopefully you're starting to realize what you can do here with the exponents if it's power of a power. So power of power, hopefully you're noticing that you are doing something with the exponents. And so this is 3 fourths, 3 fourths, 3 times, but 4 sets of those. So hopefully you noticed it by now that this is going to be 3 to the 4th to the what power? 12. Because you can multiply, so when it says the starting problem, the final exponential notation, from here to here, what do you notice? Well, when you have powers of a power, you multiply the two exponents. So when you taken a power risen to another power, a power risen to another power, multiply the exponents. Okay, so when it's a power risen to another power, you're going to multiply the exponents, right? Okay, so back here, go ahead and try these 4. So you have 3 cubed, 3 to the power 3 to 3. Now leave it in exponential notation. So 3, now these 3, this 3 and this 3, multiply, it's going to be 3 to the 9th. Okay, this one, your base is negative 4, and 5 times 2 to the 10th. Okay, now watch these. This is a negative times a negative. So you have 5, I just said negative to a negative, but that's going to be a positive 15. Okay, when you multiply them together. Then this one, careful on this one, because 0 times 3 is 0. Anything to the 0 power, remember though, equals 1. So this final answer is going to be 1, because the 0 is outside. All right, now, down here, you're going to combine the properties. So here we have product of powers property, like you're multiplying and you're dividing. So what I'd recommend here is go ahead and simplify up here first. Well, multiplication of bases, remember when you multiply by the same base, you add the exponents. So that's going to be 5 to the 7th over 5 to the 5th. Now that's division. Now when you divide by the same base, these 5s are the same base, divide by the same base, it's going to be subtraction. So your final answer there is going to be 5 squared. Okay, so I want you to do those two. And then I want you to look at these problems. Which expressions are equivalent to 1 over 3 to the 7th? So, and it says select all that apply. So it could definitely be more than 1. So look at these. These are all multiplication. And then they're all with the same base, which is good. They're all base of 3, so I'm good with there. But 1 over 3 to the 7th. Now remember, in order to be in the denominator there, that means that exponent is going to have to be a negative. So like, for example, this one, 3 to that negative 7, that would be 1 over 3 to the 7th. So I'll give you that one right there, but there's going to be some more. So I'll let you continue with that one. And then on this one, okay, that is not a 1. That's just a 4. That looks like a 1. That was a cut and paste job. So that's 4 to the 5th times 4 to the negative 6th, right? So Carla was asked to complete the following chart. Her teacher told her that there were some errors, but she did not share where the errors were. Help Carla to circle the error and explain the mistake. So look at the problem, look at the exponent form, the exponential notation form, and then the standard form, which means it's worked out. So like 5 squared, if that is really true for that one, that'd be 25. So standard form is just what it would look like as a number. So I want you to see where you can find the error. That is not the error, but that is really just 4. All right, then after this, there will be another alternate assignment just to do some more practice. So you'll be able to start that.